Imagine for a moment that everything you know about time is an illusion, that the ticking of your clock, the rising of the sun, even your own memories, they're not what they seem. Time, as you think you understand it, might not exist at all, not in the way your mind has convinced you it does. Good evening. Today we venture into a strange corner of physics, where Einstein's equations challenge our most basic intuitions. Time, that familiar river we all float along, may not flow the way we imagine. From relativity to quantum mechanics, we will explore why our sense of past, present and future could be nothing more than a convenient story our brains tell. This is not science fiction. It is a window into the true structure of reality. When we speak of time, most of us imagine it as a river, steadily moving from the past into the future, carrying along everything we know and experience. We mark it with clocks, calendars and memories, and we instinctively feel its passage. Yet Einstein's theory of relativity presents a profoundly different picture, one that challenges this intuitive notion. In the equations of relativity, time is not a separate universal entity that ticks uniformly for everyone. Instead, it is deeply intertwined with space, forming a four-dimensional fabric known as spacetime. Within this fabric, each event has coordinates, specifying not only where it occurs in space, but also when it occurs in time. But crucially, the when is relative. Two observers moving at different velocities may disagree on the temporal order of events, and there is no absolute universal clock to settle such disagreements. This implies that what we often think of as a universal now is merely a local perspective, dependent on the observer's frame of reference. From this perspective, the entire universe, past, present and future, exists as a four-dimensional block. This is sometimes called the block universe, a concept that suggests the flow of time is an illusion. The events we label as past are still embedded in this structure, as are those we imagine lie ahead. The so-called passage of time is not a feature of the universe itself, but a feature of how conscious beings perceive it. Each moment exists fully and completely in the space-time continuum. It does not disappear into some void of non-existence once it has occurred. Our memories and experiences give the impression of flow, but in reality the universe is more like a vast landscape, with all events laid out like points on a map. The sensation of movement through this landscape is a property of consciousness, not of time itself. Moreover, relativity introduces the concept that time is affected by gravity and motion. Clocks in different gravitational potentials or moving at different velocities measure time differently. This is not a subtle effect. Astronauts on fast-moving spacecraft age slightly differently than people on Earth, and satellites in orbit must correct for these differences to maintain GPS accuracy. These phenomena are not theoretical curiosities. They are concrete demonstrations that time is not a fixed entity. It bends, stretches and warps in response to the physical universe. What we call time is not universal but relational, defined by the geometry of space-time and the motion of observers within it. In contemplating this, one begins to see why Einstein's insight was revolutionary. It suggests that our everyday experience of time, with its relentless forward march, is not a fundamental property of reality. Instead, it is a deeply human construct, one that arises from our limited perspective as beings embedded within the block universe. The more we explore this idea, the more we realize that reality is far stranger than our senses lead us to believe, and that time, as we think we know it, may exist only as a shadow of a deeper, timeless structure. We tend to live our lives as if the present moment, the now, is the only reality, while the past has vanished and the future is yet to come. Every decision, every memory, and every expectation is colored by this sense of a moving present. Yet when we examine the universe through the lens of modern physics, this notion begins to unravel. Einstein's theory of relativity, when combined with the concept of the block universe, suggests that past, present and future are not separate realms, but equally real components of space-time. The distinction we draw between them, what has happened, what is happening, and what will happen, is largely a product of human perception. The universe does not privilege the present in any fundamental way. It simply exists as a four-dimensional structure where all events are fixed in space-time. This idea challenges the deeply ingrained intuition that the past is gone forever, and the future is open and undetermined. In reality, according to relativity, what we consider the present depends entirely on our frame of reference. Observers moving relative to one another may disagree on whether two events occur simultaneously or which comes first. There is no absolute now that threads through the cosmos like a universal marker. Instead, each observer carries their own slice of space-time, their own version of the present. In this sense, what we experience as a flowing moment is not an objective feature of the universe, but a subjective construction of consciousness. Our brains are wired to perceive a sequence of events, to impose order on the four-dimensional block, creating the illusion of temporal flow. Even more intriguingly, this perspective forces us to reconsider the nature of causality. If past, present, and future exist equally, then what we think of as cause and effect is a local narrative, not an overarching principle etched into the fabric of reality. The so-called arrow of time, that seems to dictate everything from the cooling of coffee to the aging of stars, may emerge from statistical patterns, rather than any fundamental temporal order. In this sense, the present is merely our conscious point of reference from which we interpret correlations in the universe. It is a moving viewpoint, but the underlying structure of reality is fixed, unchanging, and timeless. Philosophically, this has profound implications. We begin to see that memory, the past we cling to, and anticipation, the future we plan for, are not windows into changing reality, but ways of navigating the four-dimensional landscape. Our lives unfold in a space-time that contains every event simultaneously, yet we experience it sequentially. This does not diminish the importance of our choices or the beauty of our experiences. Rather, it situates them within a deeper, more intricate reality where what we call the present is simply the perspective from which consciousness interprets a universe that is far grander and more timeless than our senses suggest. One of the most compelling aspects of our perception of time is the sense that it flows in a particular direction from past to future, from order to disorder. This is the so-called arrow of time, an idea that seems obvious in everyday life. We remember the past but not the future. Ice melts in a warm room but never spontaneously reforms, and our bodies age relentlessly. Yet when we examine the fundamental laws of physics, we find a striking contradiction. The equations that govern gravity, electromagnetism, and even the behavior of atoms are largely time-symmetric. They do not prefer a direction. If we were to reverse the motion of all particles in the universe, the laws themselves would still hold. The arrow of time that we experience is not built into the basic structure of physical law. It emerges from statistical tendencies and probabilities rather than fundamental rules. This brings us to the concept of entropy, a measure of disorder or randomness. Entropy is central to the second law of thermodynamics, which states that in an isolated system, entropy tends to increase. This tendency gives rise to the familiar sense of time moving forward. Heat spreads, structures decay, and complex systems break down. Yet entropy is not a law that dictates how each particle behaves in isolation. It is a statistical statement about large ensembles of particles. The directionality we perceive is a macroscopic effect, not a microscopic necessity. At the fundamental level, the universe does not distinguish between past and future. The growth of entropy is what gives our consciousness a narrative, a sense of progression, and the illusion of temporal flow. Even more intriguing is the realization that the universe began in a state of extraordinarily low entropy. The Big Bang was not just an explosion of matter and energy, it was a highly ordered condition from which the arrow of time emerged. The increase of entropy since then has created the temporal asymmetry we experience. But this asymmetry is a property of initial conditions rather than a law of physics itself. In other words, the reason we remember the past and anticipate the future is not because the universe enforces a direction in time, but because the universe started in a very special state. Our perception of time's flow is intimately linked to this cosmic condition, highlighting the subtle interplay between the fundamental laws of nature and the statistical patterns that govern the unfolding of events. This perspective reveals that the arrow of time is both real and illusory. It is real in the sense that we encounter irreversible processes, aging and decay in daily life. But it is illusory in the sense that these processes emerge from statistical tendencies rather than an inherent temporal structure of the universe. The flow of time, the passage from past to future, is not a universal feature of reality, but a phenomenon that arises from the interaction between fundamental laws, initial conditions, and the way complex systems, including our brains, interpret them. By understanding this, we gain a deeper appreciation of why time feels the way it does, and why Einstein's vision of a block universe coexists with the arrow of time. The universe may be timeless at its core, yet within it, the narrative of entropy gives rise to the temporal story we experience so vividly. When we turn from classical physics to quantum mechanics, the picture of time becomes even more enigmatic. In the microscopic world of particles, atoms, and fundamental forces, events do not always follow the neat, continuous sequences that we observe in daily life. Instead, quantum systems exist in superpositions, where multiple possibilities coexist simultaneously, and outcomes are only realized when a measurement is made. In this framework, the familiar flow of time begins to lose its meaning. The evolution of a quantum system is described by the Schrödinger equation, which remarkably is fully time-symmetric. It does not single out a preferred direction. If we reverse the sequence of events at the quantum level, the fundamental equations would remain valid. This suggests that beneath the surface, time itself is not a fundamental requirement of physical law, but rather an emergent phenomenon. The implications of this are profound. Consider entangled particles separated by vast distances whose properties remain linked regardless of the space between them. Changes to one particle appear to instantaneously influence its partner, defying the classical notion of causality. In such situations, the conventional sequence of cause and effect seems to break down. If time is not a rigid backdrop but a feature we infer from correlations and interactions, then the universe at the quantum level is essentially timeless. Events exist in relation to one another, but the familiar ordering we impose, the past leading to the future, is a construction of macroscopic observation rather than a fundamental rule. In other words, the microscopic world operates in a realm where the classical narrative of time simply does not apply. This timelessness becomes even more pronounced when we examine the attempt to unify quantum mechanics with general relativity. In certain approaches to quantum gravity, such as the Wheeler-DeWitt equation, time disappears entirely from the fundamental description of the universe. Instead of a dynamic evolution of states over time, the universe is described as a static wave function encompassing all possibilities. Change and motion, the very essence of temporal experience, emerge only when subsystems are observed relative to one another. Time is no longer an absolute parameter, but a relational concept that depends on context. This challenges everything we take for granted about history, memory, and expectation, revealing that the sequence of events is not woven into the fabric of reality itself, but arises from the way observers interact with the universe. What this suggests is both humbling and liberating. The world we experience, with its flowing seconds and hours, is a higher-level construct, a narrative our consciousness weaves to make sense of patterns in a fundamentally timeless quantum reality. At its core, the universe does not care about past or future. It simply exists, with all possibilities encoded simultaneously in its structure. Our sense of progression, of cause and effect, and of the passage of time is a bridge between the timeless laws of quantum mechanics and the ordered macroscopic world we inhabit. Understanding this challenges our deepest intuitions, but also offers a glimpse of a universe far stranger, more intricate, and more elegant than the one we thought we knew. Our perception of time is intimately tied to consciousness itself. While physics describes a universe that can be timeless, static, or symmetric with respect to time, our lived experience tells a very different story. We perceive a continuous now, a sequence of moments flowing inexorably from past to future, and we organize our memories, plans, and actions around this perceived flow. But if time, as physics suggests, is not fundamental, then the sensation of its passage must arise from the workings of the mind rather than the universe itself. Consciousness constructs a temporal narrative, linking events in a coherent sequence that allows us to navigate the world and make sense of our experiences. This is not merely a philosophical conjecture, it is a practical necessity. Without a sense of temporal order, decision-making, learning, and even perception itself would become chaotic. Neuroscience provides clues about how this temporal narrative is formed. Our brains continuously process incoming sensory data, integrate it with memory, and project predictions about the near future. Neurons fire in complex networks, creating patterns that encode sequences of events. The brain then presents these patterns as a unified experience of time passing. This is why we remember the past but not the future, why we anticipate events, and why a moment of consciousness feels like a flowing point on a timeline. It is not that time exists objectively in the way we perceive it. Rather, consciousness imposes a subjective order onto a universe in which all events past, present, and future already coexist in the block structure of space-time. Our mind effectively carves out a moving slice of the universe to interpret, giving rise to the illusion of temporal flow. This insight has profound implications for understanding reality. When we consider phenomena like déjà vu, the perception of simultaneity, or the distortions of time under extreme conditions, such as near light speed travel or high gravity, we begin to see that the human experience of time is malleable, constructed, and deeply dependent on perspective. The arrow of time that governs our sense of cause and effect is at least in part a psychological phenomenon arising from memory, attention, and the brain's predictive mechanisms. Consciousness not only perceives time, it organizes it, compresses it, and interprets it, creating the narrative thread that binds experiences into a coherent life story. Moreover, this perspective bridges the gap between physics and philosophy. It allows us to reconcile a timeless universe where the laws of nature do not single out a preferred moment with the undeniable human experience of temporal flow. The arrow of time, the passage from past to future, and the sensation of now emerge from the interaction between consciousness and the underlying structure of reality. Our brains translate a static block universe into a lived sequence of events, providing continuity, coherence, and meaning. In this light, consciousness is not merely a passive observer of the universe, it is an active interpreter, weaving the fabric of time from a reality that, at its deepest level, may be entirely timeless. If time is not fundamental, and if past, present, and future coexist within a timeless structure, the implications for our understanding of reality are profound and far-reaching. At first, it can feel disorienting to consider that the universe does not operate according to the familiar rhythm of seconds, minutes, and hours, or that what we call the future may already exist alongside the past. Yet this perspective opens a door to a deeper, more elegant understanding of the cosmos. It suggests that the universe is not a series of events strung together like beads on a string, but a coherent, four-dimensional tapestry in which all occurrences, everything from the formation of stars to the firing of neurons in your brain, exist simultaneously. Time, then, is less a river and more a lens through which consciousness interprets the underlying structure of reality. One of the most striking consequences of this view concerns causality and determinism. If the block universe is accurate, the traditional notion of causes producing effects sequentially may need to be reconsidered. Events do not unfold because of a dynamic force pushing them from the past to the future. Rather, they are embedded in a relational structure where patterns and correlations define what we perceive as causal connections. The apparent flow of time, with causes preceding effects, arises because our conscious experience navigates this structure in a particular way. From a cosmic perspective, all moments exist equally, and what we interpret as the unfolding of events is a local perspective, dictated by how observers like ourselves interact with space-time. This challenges our intuitive sense of free will, but it also reframes it. Rather than being constrained by a linear timeline, our choices can be seen as meaningful acts within a fixed, intricate pattern that encompasses all of reality. Furthermore, the timeless perspective has profound implications for physics and cosmology. Concepts such as the beginning of the universe, the Big Bang, or the ultimate fate of everything take on a new significance. The universe need not start or end in the conventional sense, because all points in space-time exist as part of the block. This does not diminish the importance of scientific observation or experimentation. Rather, it emphasizes that our measurements and models capture only a slice of the total structure. By understanding the universe as timeless at its core, physicists can explore questions about quantum gravity, the unification of general relativity and quantum mechanics, and the nature of reality itself with a fresh conceptual framework that does not rely on time as a fundamental parameter. Finally, this view invites reflection on the human experience. It reframes mortality, memory, and legacy. Our lives, like everything else, are part of a larger eternal structure. Our awareness of time's passage, while psychologically essential, is a perspective we impose upon a timeless reality. Recognizing this does not diminish the richness of experience, rather it enhances it, offering a sense of connection to a universe that is both orderly and vast beyond comprehension. In embracing a timeless perspective, we begin to see reality not as a fleeting sequence of moments, but as a unified, intricate pattern, where time is a lens of perception and consciousness serves as the interpreter of the cosmos' deepest truths. The universe is both stranger and more beautiful than our instincts suggest, and understanding its timeless nature allows us to glimpse the elegance that underlies existence itself. As we reach the end of this exploration, it becomes clear that our everyday experience of time is only a shadow of a far deeper reality. We began by seeing how Einstein's relativity dissolves the notion of a universal now, revealing a block universe in which past, present, and future coexist. We examined how entropy gives rise to the arrow of time, creating the illusion of flow in a fundamentally symmetric cosmos. We ventured into the quantum world where events are not strictly ordered and timelessness emerges as a natural feature of reality. We reflected on consciousness, recognizing that the sensation of time passing is not imposed by the universe but constructed by the mind. And finally, we considered the broader implications. A universe where time is not fundamental challenges our notions of causality, free will, cosmology, and even the meaning we assign to life itself. Taken together, these insights suggest a universe far stranger and more elegant than our intuition allows. Time, as we perceive it, is a practical convenience, a lens our consciousness uses to interpret the intricate, timeless structure of reality. Yet within this lens lies the richness of experience, the drama of cause and effect, the beauty of memory and anticipation. The cosmos is not a fleeting sequence of events, but a vast interwoven tapestry where all moments are equally real, waiting for consciousness to illuminate them. Understanding this does not diminish our experience, it deepens it. It invites humility before the universe's subtlety, curiosity about the nature of reality, and awe at the way human perception carves order from timelessness. To grasp that time may not exist in the way we think is to glimpse the universe not as a simple stage where events unfold, but as an intricate structure, elegant, unyielding, and eternally present. And in that realization we find a profound connection, not only to the cosmos, but to the very process of understanding itself. In the end, Einstein was right in ways we are still only beginning to comprehend. Time does not exist as a river, as a universal measure, or as an absolute sequence. It exists as an experience, a narrative, and a perspective, a beautiful illusion born from the interplay of physics, consciousness, and the extraordinary order of the universe. To recognize this is not to abandon our lives in the present, but to see them in the context of a reality far richer and more enduring than we could have imagined.